This is another past paper question from paper 1, AQA A-level chemistry. And this question is about pH. And this is one of the guaranteed topic in your paper 1 exam. So please make sure that you know exactly how to calculate the pH for different solutions. In this question, it's about water and about alkaline solutions and how to calculate the pH of these. So first one is about the ionic product of water, Kw. They give you this value at 40 degrees. And they want you to give the expression of Kw. This is a standard question and very easy one. Kw equals the hydrogen ion concentration times the hydroxide ion concentration. And then calculate the pH of pure water at 40 degrees. So the pH is minus log 10 of the hydrogen ion concentration. The hydrogen ion concentration equals the hydroxide ion concentration. So we can find the hydrogen ion concentration from the Kw expression because it will equal the square root of the Kw. They provided you with the Kw in the question, which is 2.92 times 10 to the minus 14. And when you do your calculation, this is going to equal 1.71 times 10 to the minus 7, of course, mole decimeter minus 3. And now we need to find the pH or calculate the pH, which is minus log 10 of this hydrogen ion concentration. Do your calculation, and this is going to be 6.77. So the pH is 6.77. Please make sure that you give them what they want because they said give your answer to two decimal places. So make sure that you put your answer with two decimal places. The second question is now about mixing a solution of a strong acid with a strong base. So 35 centimeter cube of 0.15 mole per decimeter cube aqueous sodium hydroxide mixed with 20 centimeter cube of 0.1 mole per decimeter cube solution of hydrochloric acid. And they want you to calculate a pH of the solution form if the temperature was 40. Now we need to find the moles of each of the acid and the bases and the base at the beginning, and then find which one is in excess. It's clear that, of course, the sodium hydroxide is the one in excess. And now we need to find the concentration of the hydroxide in order to find the pH. So first of all, let's count or find the number of moles of sodium hydroxide at the beginning. That equals the concentration, which is 0.150 times the volume in decimeter cubed, which is 0.035, and that will give you the moles of sodium hydroxide, 0.00525 moles. Now let's find the moles of HCl, and that will be equally the same, 0.1, which is the concentration, times the volume, 0.02, and decimeter cubed, of course. So this is 0.002 moles. So the remaining sodium hydroxide or the excess sodium hydroxide remaining moles of sodium hydroxide will be the difference between these two because the reaction is 1 to 1. So now it's the difference between these two. So this is going to be 0.00325 mole. Now we need to find the concentration of the hydroxide ion because we're going to need to use it in the calculation of the pH. And because of sodium hydroxide is monobasic, there is only one hydroxide ion. So it's basically the same like the concentration of sodium hydroxide. So we know that the concentration is the number of moles over the volume in decimeter cube. So this is the moles we calculated, 325, and the volume now it was 35 centimeter cube added to 20 centimeter cube. So the total volume is 55 centimeter cube. So in decimeter cube, that will be 0.055. And that will give you the total number of moles, which is 0.0591 moles of mole per decimeter cube. So that's the concentration of the hydroxide ion. Now we need to find the hydrogen ion concentration. For the strong base, the hydrogen ion concentration equals Kw over the hydroxide ion concentration. So the Kw was given to us in the first question or at the beginning, which is 2.92 times 10 to the minus 14 over the hydrogen ion concentration we calculated, which is 0.0591, and that will give you 4.94 times 10 to the minus 13. Now we have the hydrogen ion concentration, or what we need to do is to calculate the pH, which is going to be minus log 10 of the hydrogen ion concentration. Remember to give your answer to two decimal places, and that's 12.31. So that's the pH of the solution.